my name is Laurent Lessard. I'm an associate professor of mechanical and industrial engineering at Northeastern. I'm also a core member of the Institute for Experiential AI. My research is in control theory and optimization. So just really quickly, what are those things? Control theory is the study of feedback in engineering systems. Any system with an on-off switch uses some form of feedback. So for example, the thermostat in your home uses feedback. It's constantly making adjustments. Autopilots on an airplane, automatic braking in a car, any sort of, and for the most part, control systems work really well. We don't tend to study them that much or think about them that much because they tend to work really well. So imagine the power grid. Imagine, a fleet of self-driving vehicles that all have to coordinate with each other. Situations that are large, distributed, decentralized, those tend to be a lot more difficult to control, mainly because there isn't a central agent that gets to have all the information and make all the decisions. In many cases, we don't actually want that. We don't want there to be a single point of failure in the power grid. That would be very dangerous. So when there isn't a single centralized agent and everybody's kind of making their own decisions, not everybody has access to the same information. So some people have more information about certain things, other people have more information about other things. And even if they're trying to cooperate and work together, it's still difficult to come up with the best possible strategies. So that's one thing that I study. I study decentralized distributed control. And I also study how optimization plays a role in these kinds of problems. Optimization is kind of like control. It's sort of making the best decisions, right? Although control tends to deal with situations that are dynamic and changing over time, whereas optimization tends to be more static. What we're finding is that in a lot of modern systems, there is a clash between these two ways of thinking. On the one hand, you have the folks that do machine learning and data science that think from more of an optimization perspective. And then you have folks that actually do design control systems for cars and things like that. They think more from a controls perspective. But then when you have systems that combine both, right? If you have a self-driving car, there's a lot of optimization going on, path planning, any sort of image analysis that is happening for the various sensors. So that takes an optimization viewpoint. But then it's also a car. It needs to be controlled. And from that point of view, it's a control system and people want to think of it that way. And these are two communities of researchers that don't really talk to each other. So I'm kind of interested in both of these things and the problems that arise when we try to build complicated systems that involve both kinds of thinking.